we're going to learn about the chain rule. Now, the chain rule can be a little bit confusing because it deals with basically composite functions. And it's very straightforward. Once you learn how to apply it, you'll just do it automatically. And let's look at what it says. It says, suppose I have a function y, which is a function f, and that is a function of u. And it's differentiable. It's a differentiable function of u, and u is a function of x. U is equal to g of x, is also a differentiable function. Then y is f of g of x is also differentiable, and the derivative with respect to y, with respect to x of y is the derivative of y with respect to u times the derivative of u with respect to x. Or, you can put it this way, the derivative with respect to x of f of g of x is equal to f prime of g of x times g prime of x. Now, let's look at, let me get my pen here. Okay, there we go. Let's see if we can do this derivation. Let's let this function right here, let me do y prime, the derivative with respect to x of y is equal to the limit as, let's do it this way, as x approaches c of f of g of x minus f of g of c divided by x minus c. Now, and of course, x doesn't actually equal c. Now, let's do a trick. You know, the trick to these proofs is always a trick. Let's look at the limit as x approaches c. That's not changing. But what I want to do is multiply through by 1. So let me write my numerator here. F of g of x minus f of g of c. All right. And I'm going to do this right here. Let's see. I'm going to show you what I'm doing as I'm doing it because this is a little confusing. X minus c. Now I want to make this a derivative. So down here I need g of x minus g of c. Now in order to have that, okay, I'm going to put brackets around these. What I do to the denominator, I have to do to the numerator. So this is g of x minus g of c. Ah, do you see what I've done here? Now, this is equal to the limit as x approaches c of f of g of x minus f of g of c divided by g of x minus g of c times the limit as x goes to c of g of x minus g of c divided by x minus c. Now, this first one is, of course, the derivative of g of c. And the second one is, of course, g prime of x. The hardest thing about this is figuring out which formula is which. So the first thing you need to learn how to do is decompose your functions. Suppose we look at this first one. Y is 1 over x plus 1. And what we're doing is we're looking for one function to be the overall function, the f of u, and then the inner function to be more the variables. You want to kind of step back and look. You kind of blur your eyes and you look at this one. You see this is kind of a 1 over x sort of situation, or maybe a 1 over u situation. So if I were to let y equal 1 over u, then what is my function of x? Well, my u is x plus 1. All right, what about this one right here? Let's decompose this one. The overall function that seems to be driving everything is, of course, sine. So let me switch this. So y, if I say this is sine of u, then what is u in here? This is 2x. Now let's look at this one right here. The overall driving function here is y equals what? The square root of u. And if the overall function is y is the square root of u, then u, of course, is 3x squared minus x plus 1. Now you're going to do some of these decompositions where you don't actually have to do the derivative. But let's apply the chain rule. All right. So in this case, my overall function is y is equal to what? U cubed. And then my u is x squared plus 1. So what is dy du in this case? It's 3u squared, all right, times u prime. And so what is the derivative of u with respect to x? It's just 2x. Now you don't have to write all this out. You'll get to where you can just do this. You have an inner function and an outer function. So let's see, and the inner function is of course the x squared. So this becomes du dy du times du dx. Now I'm looking for dy dx. Now you're going to be wanting to tempt it to go, oh, well, those cancel and it's equivalent, but it's really not the same thing. I did that once. Really made my calculus teacher angry at me. All right, so dy du is 3u squared. I guess u prime there is just u, so all right, times du dx, which is 2x. Now it goes plug back in, 3. Where's my u? U is x squared plus 1 times 2x. All right. I'm not going to try and multiply all this out, but I will make it 6x x squared plus 1. And I'm going to be really honest, I'm not satisfied with the way I explained that. So let me do another one. Suppose I have, let's do a trig function. Let's do y equals cosine of x squared. All right, the overarching function here is y is cosine u. So dy du is, derivative of cosine is negative sine. And then, of course, u in this case is x squared. And du dx is 2x. So the derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. So dy du is minus sine of u. I don't know why I'm doing it at an angle here. Times du dx, which is 2x. Plugging my u's back in, and I want to bring this forward. This is 2x negative sine of x squared. Okay, your turn. Turn off the video and do the notebook problems. Turn it back on and we'll finish up. Now the general power rule says if I have y is equal to some function of x, and that whole thing is raised to the nth power, where n is differentiable and x and n are rational, then the derivative of y with respect to x is n, so you bring the power down, u to the n minus 1 times the derivative. This is a specific application of the power rule. Now, this is all of the functions that we have been learning. We're going to have a quiz next time. You're going to need to be able to write them by name. You're going to be able to write the chain rule, the different trig functions, the different algebraic functions. You need to know the constant rule, the product rule, constant multiple rule, etc. Now let's do a couple of problems. Suppose I want to do f of x is equal to 2x squared minus 5x plus 1 quantity squared. I'm not going to break this up. I'm just going to do this. Here's my inner function, all right? So when I do df dx, I see this is my inside function, and this is what actually goes on in my head. So I'm going to hold that constant. This is raised to the power, so this becomes 2 times my inner function. Now 2 minus 1 is 1. And now I need to take the derivative of the inside. So the derivative of 2x squared is 4x minus 5. And, you know, I'm interested in you being able to do calculus, not to multiply all this mess out, but we're going to simplify this a little bit. 8x minus 10 times 2x squared minus 5x plus 1, but you don't have to do any more. Now, what if we have this funky power here? Same thing, my inner function. So when I take f prime, okay, I bring the power down, so it's 2/3 times 2x squared minus 5x plus 1. Reduce the power by 1, so this becomes negative 1/3. Take the derivative of the inside. 2x squared minus 5x. Well, it would help if I could do a derivative, couldn't it? Ha. Got carried away, just started writing things down. Okay, so this derivative is 4x minus 5. We can rewrite this as 8x minus 10 divided by 3, 2x squared minus 5x plus 1 to the 1/3. But folks, let's not do any more because that's just a mess. All right, what if we have a trig function? Trig functions are always fun. Let's see, the derivative of y with respect to x is going to be, this is my inner function. So let me do the derivative of my outer function. Derivative of sine is cosine. And now I'm going to take the derivative of the inside function. And the derivative of 3x is, of course, 3. So this is just 3 cosine 3x. Oh, what if it gets even more complicated? All right. Y prime is going to be 5. Now I'm going to hold this constant. This is my inner function. Derivative of cosine is minus sine. And make sure you put your parentheses here. And I'm going to keep that constant. All right. Times the derivative of what's inside. The derivative of 2x cubed is 6x squared. I am going to rewrite this as 30x squared, pull out my negative sign, sine 2x cubed. Now it's your turn. When you're done putting these in your folder, stop the video.